Good afternoon, everybody. I'm going to do the derivation of this method called the integrating factor method. So let me put that to the side here. Integrating factor method. Okay, so the integrating factor method is based on this form right here. If a differential equation takes on the form dy dx plus some function of x times y is equal to some other function of x, and it happens more often than maybe you'd think. So this isn't just some random hey, guess what we know situation, because this can come in multiple forms but be simplified into this form here written in yellow. Now, whoever came up with this idea was a very bright individual, and they were thinking, honestly, this integrated factor, I'm going to call it I of x. They multiplied both sides of this equation by what they end up calling the integrated factor I of x. And the reasoning for that is because when distributed on the left side, okay, if I distribute I of x, that's I of x times dy dx plus I of x times p of x times y is equal to I of x q of x what's brilliant is that this right here ends up being the product rule. Right? If I were to take the derivative of the following expression with respect to x, it actually comes out to be that expression right there. So think of it logically. If I were to find the derivative of two functions multiplied together, well, it would mean that I'd take the derivative of the first function, which would be dy dx, times the second left alone, which is I of x. So this expression here is the derivative of y with respect to x times I, plus the first left alone, which is y, times the derivative of I of x, which would be I of x times p of x. So implied in this is that the derivative with respect to x of I of x is going to be equal to I of x times p of x. All right, now, why does this even matter? Because I can figure out what I of x is in terms of x, and then we'll be able to do some work with that. So bear with me here for a moment. I'm going to call this expression here I prime of x. Okay, I prime of x would then be equal to I of x p of x, and therefore p of x would be equivalent to I prime of x over I of x. Now, why is that helpful? Because now I can find what I of x is in terms of p of x. Check this out. If these two are equivalent, then the integral of both of them with respect to x should be equivalent. And this is the perfect setup on the left side for a u substitution. So I'm going to set u, let's go with a different color, see if I can go, yeah, let's go white, here we go. If u equals I of x, then du is equal to I prime of x dx. Therefore, this integral is equivalent, I'm going to do a substitution here, to 1 over u du. And that, of course, is equal to the integral of p of x dx. Now, I'm not going to do anything with p of x because I don't know what p of x is. I'm talking generally only, just general. So let me work my way back up over here. That means that the integral of 1 over u is the natural log of u, and u is I of x. Therefore, I get the natural log of I of x is equal to the integral of p of x with respect to x. Okay, so I of x can be written in terms of p of x. I of x is equal to e to the power of p of x dx. E to the power of the integral, of p of x dx. All right, so this is really cool. I can find the integrated factor, and I can work through some problems with it. Now, some pieces that are going to be important for you to kind of have and grasp. Okay, let's put those over here in a box. And you're going to want to hold on to these during these integrated factor method differential equation situations. Okay, so first thing you want to be aware of is that this form, dy dx plus p of xy, is equal to q of x. You got to be aware of that form. That is the A number 1 situation. Okay? So you got to identify p of x, you got to identify q of x. The next thing you need to know is that I of x is equal to e to the integral of p of x dx. Okay, and the last thing that you need to be aware of is that we're going to use the fact that the product rule shows up here to put this in a separable form. All right, and then begins the fun. We'll look at a few questions in the remainder of this lesson. All right, see you in our day number whatever this is video. All right, see you.